everyone. Today we are going to be talking about relative frequencies and how to use relative frequency to tell how often an event is going to occur. So first we need to know, well, what is relative frequency? Because that's kind of just a weird word. Well, relative frequency is used when you conduct an experiment. It measures probability and it's the fraction or percent of time that an event is going to occur. So relative frequency is the fraction. So we're looking at fractions, or the percent of time that an event occurs. Okay, so it's a way for us to measure. It's a way for us to measure how often something's going to happen using fractions and percents. So we're going to use fractions and percents. We're going to be using frequency tables, and a frequency table uses tally marks. So let me set up the experiment for you for this first one, and then we'll go through it. So it says you flip a bottle and you record the number of times it lands upright and the number of times that it lands on its side. So we have bottle flipping. Okay, the number of times that it lands upright is shown in this frequency table using tally marks. And so let me make that real quick. And then the number of times it lands on its side. So this is the data. So every time we flip the bottle, we put a tally mark. So if it lands upright, we would put a tally mark. If it lands on its side, we would put a tally mark here. So upright, it landed twice, and on its side, it landed 23 times. So there's 5, 10, 15, 20, and 23. Okay, so there's our experiment. So after there were a total of 25 flips. And we can tell that because we're going to add up 2 here plus the 23 here, and that equals a grand total of 25 flips. So 2 out of the 25 was upright. 23 out of 25 was on its side. So we're going to talk about the relative frequency. They want to know how often does it flip on its upright? So how often is it upright? So relative frequency we're going to make a fraction that uses the number of times the event occurred on the top over the total possible times, or the total times of the experiment. Okay, so in this question A, we want to know part number 1 is how often upright. What's the fraction for upright? And number 2, on its side. So we're just going to make a fraction using this information. So how often is it upright? It's upright 2 out of 25. So here's the number of times the event. The event is upright. Total experiment was 25. Okay, now we can look at on its side. So when we're looking at on its side, we had 5, 10, 15, 20, 23 tally marks for on its side out of 25. We could turn these into percentages by multiplying this to get to 100. Multiply it by 4. So if we were to multiply this by 4, this would give us 8 out of 100, or 8% of the time. So this one could be 8% because it can be a fraction or a percentage of the time. Okay, let's do another example so that you can tell the relative frequency. Okay, the relative frequency, this time instead of using a what is it? A frequency table. Oh my gosh, my brain. A frequency table. They are going to use a graph. And I think I'm going to pause real quick and then set up the graph for you so I don't have to draw it out. Because if I draw out the graph, it's going to be, I think, harder for you to see. So give me just 1 second. Okay, also we probably should talk about this 8% as how likely is it to happen? Well, 8% tells us that it is unlikely to occur, right? Flipping it upright is unlikely. It's not impossible because it's been done, but it is unlikely to occur. So we would probably also label this as unlikely. Unlikely to occur. So just combining the last 2 lessons. Okay, the next one, the next example that we're going to use is going to use a number cube that we're going to roll. So it has a chart that looks like this, if I can make it just a smidge bigger. And on our number chart, it says the number of times rolled and the number so we number rolled the number that was rolled with the times that we rolled the cube. Okay, so you have 2 parts to this question. So our experiment is rolling a number cube 50 times. So the experiment is rolling a number cube 50 times. That's our experiment. We rolled it 50 times. These are the results right here that you can see. Those are the results. We rolled a 1 10 times. We rolled a 2 4 times. We rolled a 3 8 times, and so on. So you can just use those bar graphs there to help you know what you actually rolled. Okay, so let's look at what the question. It wants us to describe the likelihood of rolling a prime number. So it says to describe the likelihood of rolling a prime number. Okay, we know prime numbers are 1 and themselves. So 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 is not, because you can't, 2, 4, and 1 make a prime number. So that doesn't work. So we have 1, we have 2, we have 3, and we have 5. So let's talk about how many times each of these happens. So when we rolled a 1, we rolled 10 times, 10 out of 50. Rolling a 2 was 4 out of 50. Rolling a 3 was 8 out of 50. And rolling a 5 is 11 out of 50. So we're just going to add all of these up and figure out what the likelihood is of rolling a prime number. So 10 and 14, 8 is 22, and then we have 33. So 33 out of 50 of the rolls were prime numbers. So 33 out of 50 are prime numbers. So the likelihood of rolling this, let's go ahead and turn this into a percentage, is 66%, because we can divide by 2 to get us to 100. So if we look back, 66% is likely, it's closest to 75, so it is likely, this one is likely that we are going to roll a prime number. Okay, it's going to be your turn now to do a try it. So we're going to go ahead and turn the page and do a try it. Let's get rid of this. We don't need that anymore. Okay, you are attempting to make 3-point shots. So your try it, your experiment is 3-point shots on the basketball court, and you represent the numbers made by the numbers missed in a frequency table. So made and missed. Okay, the numbers made are 9. So you made 9 shots. Good job. Way to be a baller. All right, so you made 9 shots, but you missed 6. That's where that practice and determination comes into play, right? Okay, I want to know, what is the likelihood that you make your next shot or that you miss your next shot? So the likelihood of shots made and 2, what's the likelihood of missing your next shot? Okay, go ahead and hit pause right now so you don't hear me solving. And then when you are ready, come on back and check your level of understanding. All right, so when we make our baskets, we made 9 out of 15 total shots. So 9 out of 15 total shots. Well, we need to get this to be to get out of 100%, right? So we're just gonna do 100 divided by 15, and that gives us that number. So we're going to multiply that by 9, and we get 60%. So we have a 60% chance of making our next shot. So let's look back. Is that likely? That is likely to make. We are likely to make our next shot. We are likely to make it because we had a 60% chance. Okay, missing our next shot. So if we're going to miss it, we're going to do 6 out of 15. So 6 out of 15 is our shots there. And if we do 100 divided by 15 again, we get this number. We're going to multiply that by 6. And that gives us a 40% chance. Or we could have just taken 60 minus 100 and gotten 40% left over. 40% is less than 50%, so it's probably unlikely. It's probably unlikely, right? Unlikely to equally likely. That we're going to miss it. Okay, so it's equally likely that we're probably going to miss it. We're really close on here, so it could be likely. This one is even really close. It's really close to 50%. So this one's probably likely or equally likely. Could be closer to 50%. It's really close to a 50-50 chance. There's not enough data here to show if we're going to make it or miss it. So, okay. So close to 50% on that one. All right, go ahead and answer your essential question. How do we find the relative frequency? So how do we find the relative frequency? And then put your level of understanding out to the side. Where are you at with your learning? When you are finished, you can come on back to the Google Meet and ask for help, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.